Hi, hello everyone. So this is the video dealing with section 1.6, transformations of functions, and this is the last part, part 4, where we go over some examples. Now, so remember, we've covered already all the 8 transformations, and I'm going to remind you what they are, but we're only going to be focusing on the primary 6. Okay, so here are the transformations. So I have translations, which is a shift up or down. Those are the vertical shifts. We have the shift left or right. Those are the horizontal shifts. So if you have a function and you have a plus or minus outside of the function, the plus whatever number would be a shift up, minus the number would be a shift down. If we have a function where this number is affecting or under the influence of the function, then it's either a shift left if it's plus or a shift right if it's minus. Then we have the reflections. We have a reflection on the x and we have a reflection on the y. So a reflection on the x would be a minus outside of the function or in front of the function. Whereas, so this is a reflection on the x, whereas a minus under the influence of the function inside of the function would be a reflection on the y. So these are the 6 primary transformations, but we still have the dilation, right? So the dilation would be if I have a number multiplying the function, okay? Obviously a number other than 0. So if the a is a number positive greater than 1, then this is a stretch, depending on how you look at it. And I'll remind you what it looks like because I have an example here. Even though we're not going to graph this, this number here's a dilation. Okay. If this number here, so greater than 1, the function will grow faster. And if it is a number smaller than 1, but it's still greater than 0, this means that the function will grow slower. Okay, so some people give different names to these things. And like I said, on functions that are not sine or cosine, it's very, very difficult to see. I'll show you when we get to example D. So for the purposes of the exam, we're not going to do dilations. We're only going to be doing the translations or reflections. So those are easy enough for us to see. Okay, now, so let's see, I'm going to erase this from here and we'll take a look at the examples that we have right here. Okay, so let me just clean this. And so remember that all of these examples, they begin by first having us identify the parent function. So in this case, it's the x squared or the quadratic function. This would be the square root. This would be the absolute value. This would be the cubic, and this would be the cubic root. So after we identify the parent function, it will be useful to identify the transformation. This will be a shift up by 2 units. This will be a shift right by 1 unit. So you have to remember that the plus or minus outside of the function is a shift up or down, and the plus or minus under the influence of the function. So you see here the -1 is being impacted by the x squared. So it is a shift, a horizontal shift, but in this case it's minus is a shift right. All right, so after identify the parent function and the transformations, what we do is we graph the parent function. So in this case, it's x squared. So here is x squared, and you focus on the center point. On the x squared, the 0, 0 is the center point or the key point. And then you do whichever transformation you want to do first. Okay? I am going to do maybe this transformation first, which is 2 units up. So from the 0, 0, now I am located here, and this is the location 0, 2, and then I regraph the parabola passing through that point. And then I do the other transformation, which in this case is 1 unit to the right. So this point, this the center point is going to move this way 1 unit. So I'm going to locate it here. And this is going to be the location now 1, 2. And I regraph the parabola passing through that point. Notice that I don't really need to find this location right here. It's not necessary. There's no confusion that this location is above the x-axis. Okay? If you want, you're more than welcome to find maybe one location here for the parabola, and we can do that. Maybe let's say that this is the x equals -1, and I want to find this point. So all you have to do is find y at -1. So -1 minus 1 square plus 2. So this is -2 square plus 2, or 4 plus 2, or 6. So this is the location -1 and 6, but it's not necessary. Sometimes we will have to find the y-intercept, and I'm going to show you in the remaining cases where it's not clear the function is above the x-axis or below. All right, so this is the first case. Let's take a look at the second example. I'm going to erase all of this because obviously I'm going to need the space. And if you want to, you can always stop the video and take notes or pay attention more carefully. So here's the second case. I have a square root function. I have one transformation down. So this is a shift down by 1 unit. And this is a shift to the left by 1 unit. So I identified the parent function, identified the transformation. So I'm going to graph the parent function. So here's the square root function. Again, I take note of the key point, which is again at the origin, and I apply the transformation. So maybe now I am going to apply this transformation first, which is a shift to the left by 1 unit. So this location goes right here, and this new point is -1, 0. Right? 1 unit to the left. And I regraph the function. Obviously, I could have done it over here. So this is the location now, -1, 0. And then I apply the other transformation, which is down from here 1 unit. Now, I'm going to graph it on this axis, on this axis right here, because I'm going to show you a situation that happens. So when I go down 1 unit, this point goes down to -1, -1. So the question now becomes, look what happens. I'm going to do it in dashed line. I don't know if the function, which of the 3 cases it is. Does it go above the x-axis, below the x-axis, exactly at the origin? I'm not quite sure. So to clarify that, you cannot graph it whichever way you want to. There is a correct way. I have to find, in some cases, I have to find the y-intercept. So the y-intercept is when you let x equals 0, okay? So y at 0 equals value of the function x plus 1 or 0 plus 1 minus 1. So evaluate this. This is obviously square root of 1 minus 1. The square root of 1 is 1, minus 1 is 0. So notice that in this case, the y-intercept is exactly at 0. So when you graph this function, and here is your new point, right? Here's your point -1, -1 after both transformations, you have to graph the curve exactly passing through the origin, and you have to label that point. You can't graph it above or below because it would be incorrect on an exam. So sometimes we have to find the y-intercept. In the first case, we did not. It was obvious that the function was above the x-axis. In this case, it was not. All right, so this is the graph of the second function. All right, so let's do the third example. The third example is a absolute value function, okay? I recognize the parent function. I recognize this transformation as 3 units up. I recognize this transformation as 4 units to the right. And I recognize this as a reflection on the x. All right, so I'm going to do this transformation first, but before I do that, I will graph the parent function. So the absolute value function looks like this. That's the one that looks like a V. And the key point, again, is 0, 0. I will do the first transformation, which is 3 units up right here. So this new location is x0, y3, and I regraph the basic parent function. Right, so remember, you have to carry over the new location of the key point. Now, the second transformation is 4 units to the right from here. So I'm going to go this way 4 units. All right, so I'm going to position the point right here. And this is the location now for, you've added 4 units to the x, comma 3, and I'm going to regraph the function, the parent function now on this new location. So this looks like my function so far. The last transformation is the reflection on the x. So this thing is going to go this way. I'm going to do it as a dashed line because I'm going to have the same issue as I did before. I am not quite sure if it is above the x-axis, below, or exactly through the origin. I have to find out. I cannot graph it any way we want. So to do that, I am going to have to find the y-intercept. And we're going to do that by letting x equal 0. Okay, so I'm going to evaluate the function at 0, which is minus 0 minus 4 plus 3. Right, so inside the absolute value sign, I have minus 4 plus 3. Obviously, the absolute value of negative 4 is 4, but there's a minus on the outside. Right, so this is minus 4 plus 3. Obviously, minus 4 plus 3 is negative 1. So you can see that, when I erase this, that the function now intercepts, so this is 4 comma 3, the key point. The function intersects the y-axis below the origin. Okay, so this is the location 0 comma negative 1. And we need this point on your exam. Okay, so this would be, I'm going to erase this part. This would be my final graph for the example C. Okay, it's important to know that this crosses below the x-axis. All right, very good. So let's do the next example. The next example is a cubic function. I recognize the parent function. I recognize this is a shift up by 1 unit. I recognize that this is a shift right by 2 units. And I recognize this is a dilation where A is 2. So this is like a stretch. Okay, I'm going to show it now, but then I'm going to graph it without it. So I'm going to graph the parent function. So this is a cubic. Okay. Now, this is what happens when you multiply the function by a number. this number is greater than 1, which means that the function is going to grow faster. Now, normally a person would think, well, if it's faster, it would be this way, right? No. This is a typical mistake, and that's why I'm not covering dilations on these functions other than the sine and cosine function. So the number 2 here would make the function go faster, and it would look like this right here. So this would be 2x cubed. And on the negative side, it would go here. Now, if I were to copy this over here and then compare the original with the new, it's impossible to see the difference visually. So we're not going to do that. Okay, so I'm just showing you what the number 2 would be in comparison to the original parent function. If it is 2, it would be here. If it's a number smaller than 2, like let's say 1/5 x cubed, it would be there. The function grows slower, all right? Whether you call it a stretch or a shrink, it doesn't really matter. It just matters where the function is, right? It's growing faster or slower. All right, so I'm going to now, this is what we're going to do. I already showed you the transformation, but for the purposes of the exam, we're not going to do dilation. So we're going to graph this function right here. So I know it's a cubic. So I'm going to graph the cubic. I am going to record the central key point, which is again 0, 0. This is a shift up by 1 unit, so you would go right there. You regraph the parent function from this key point. So now this key point is at 0, 1. Okay, and this now is a shift to the right by 2 units. So this point will go over here. Okay, so this location is your point 2, 1. Right? From the 0, 1, you added 2 points to the x coordinate, so it becomes 2, 1. So we have the same situation from here now, from the center point. You're going to graph the cubic parent function, but so now we have the same issue. Does it go above? Does it go below? We have to check out. We can't graph it whichever way we want to. So we go back and we do the y-intercept, which we find when x equals to 0. So y of 0, we're going to replace x with 0. 0 minus 2 cubed plus 1. Negative 2 cubed plus 1. Negative 2 to the third power is negative 8 plus 1, negative 7. So you know from this that the function is crossing below the x-axis. So you have to graph it this way now. And you have to identify this location as 0, negative 7. It's very, very important. So in this case, in the first example, I didn't need to do that. In this case, I do. All right. And this is the final graph of my function, not accounting for the dilation. All right, so let's do the last case. So the last case is a cubic root. All right. And let's see the transformations. I have 2 units down. This is a shift down. I have 1 unit to the left is a horizontal shift. And this is a reflection on the y. Now, so remember, I'm going to remind you again, this will be a reflection on the x. This is what we have right now. It's a reflection on the y. Okay. All right, so I am going to graph the cubic root. This is the cubic root. The key point again is 0, 0. Okay, and this time I'm going to do the reflection first, the reflection on the y-axis. All right, so now, so it's like you have a mirror right here. and this piece goes there, this piece goes there. So let me just remove this piece a little bit from here because I need the space. So I'm going to have, sometimes it's very difficult to do this. Okay. The reflections do not change the key location of the point. And now we can do the other transformations. So I am going to maybe do this one first, which is a shift down by 2 units. So the key point will go here. So the new location would be 0, -2. And then from here, I will do this transformation, which is 1 unit to the left from here. So if my point is here, it's going to go right there to the left by 1 unit. Now, it was 0, -2. So now it becomes -1, -2. And I will graph now the function, which is this function, as you see over there. Notice that in this case, there is no doubt that the function is crossing below the x-axis, so I don't need any additional points, just the key point, which is the -1, -2. All right, so it's important that you know the parent functions, number one. It's important that you know each of the 6 transformations, number 2. And it's important that you understand that in some cases, like we saw here in these 3 cases, we needed to know the y-intercept to make sure that we're graphing the function either above, below, or exactly through the origin. Okay, so these are the 3 key things that you need to know to do the transformations on the parent functions.